We are in Chapter 8, Part 2 test review. So this is all about factoring and solving. It says factor each polynomial using their GCF. If they do not have a GCF, you may use grouping to create one. So these three right here all share a 3. They all share an M, and they do not share an M. So if I take out a 3M, what is left? I'm left with just an M. I'm left with just a 2. The n squared carries down, and then 4. I removed one M, and I'm left with an n. That's it. They just want you to factor. They want you to break up. Here, they don't have any numbers in common, but they share a C. So if I take out a C, I have 4 left here. I have 2 left here, and I'm just left with the number 4 here. Okay. If you look at the numbers, some of you are like, well, maybe it's a 3, maybe it's a 4. They all have to contain one of the numbers. Here, they all contain a 2. This is 4, 3, and 2 x's, so they all share at least 2 x's. They all share at least 1 x. When I remove 2x squared y from each term, I am left with 4 x squared y minus 2x. The y simplify to a 1, so we don't write that. Here, anything divided by itself is 1. Some kids put nothing. Be careful. Anything divided by itself is 1. Here, the GCF they have in common is a quantity, n plus 2. When I remove it, I'm left with m plus n. Or you could have rewritten them either way, m plus n times n plus 2. Same thing here. Technically, there's a 1 here. So x plus 1, x plus 1. You could also write it as x plus 1 squared. Here, there isn't a GCF. Some kids might say 4, but there isn't a 4 here. Some kids might say B, but there's no B here. A. So what you can do is there's 4 terms. Grouping should probably work. Between these two, they share an X, and you're left with 4A minus B. I want to see 4AB minus or 4A minus B again. These share a positive Y. When I remove the Y, I get 4A minus B again, and I'm left with 4A minus B times the quantity x plus y. Here, a 2 and a z is shared, so I take that out and put x plus y. Here, there's an x plus y. Technically, there's a 1 here. So 2z plus 1 is what remains when you take out x plus y. Same thing here, we're going to group again. They share a 2, they share a p, and they share a q. So when I take that out, I'm left with a q plus, write this if that helps you, 2, the p and the q simplify. And now here, if I take out a negative 2, I should be left with q plus 2. Be careful. If you take out a positive 2, you're not going to get the q plus 2 again, and then it's wrong. You want to have the same thing twice. So you're left with 2pq minus 2, the end. It says name one factor. Well, this can be a bit overwhelming, so what I do is just take out a GCF of 4x, y. You're left with 3x minus 2y plus, when you take out a 4, there's just an x and a y left. So is 4xy anywhere? No. Is there a 3x minus a 2y plus an xy anywhere? Yes. So you took out a GCF and factored that way. On the next page, it asks you to factor the difference of two squares. X plus 9, x minus 9. Here, 4y plus 5, 4y minus 5. And here, difference of two squares. Notice we took the square root, square root of 16, square root of 25. Here, the square root of 4 is 2. Now it's y to the 4th, so cut that in half, y squared, plus minus or minus plus. 16, the square root of that is 4 and 4. You do them all the same. Okay, here, Factor the quadratic trinomials. So, do you have three terms with a plus in the back? Then this sign will appear twice. Factors of 72 are 8 and 9. Do they add up to 17? Yes. Here, do you have three terms with a plus in the back? Yep. Then this sign will appear twice. Factors of 9 are 3 and 3, which give you negative 6. Do you have three terms with a plus in the back? No, so the signs aren't going to be the same. One's going to be plus, one's going to be minus. So, factors of negative 40 that give you negative 3. Well, we have a negative 8 and 5, or 8 and negative 5. Let's see, does that give us negative 3? The first one does. Down here, do we have three terms with a plus in the back? We don't. So one's going to be positive, one's going to be negative. So negative 42, we know that's 7 times 6. One of them has to be positive, one of them has to be negative. So which one gives us a negative 1? It's this one, negative 7, positive 6. Do you have three terms with a plus in the back? Yes, we do. One's going to be plus and the other one's going to be plus because this is plus. So factors of 45 that give us 18. Well, I know that's 9 and 5. That doesn't work. If I divide by 3, what do I get? If I divide by 3, I get a 1. And then 15. Does a 3? Yep, that works. Okay, this is factoring a trinomial. Number 18 says a rectangle has an area represented by this trinomial. If the length is x plus 2, what's the width? All right, well, we're talking about a rectangle. And it says the length is x plus 2. We want to find the width. Well, I know to find area, it's length times width. They tell you the area is x squared minus 4x minus 12. They tell you the length is x plus 2. So they want to know the width. Well, if it's x squared, I know it's x and x. And 2 times what gives me negative 12 would have to be negative 6. Yeah, a negative 6, positive 2 is a negative 4. So my answer is x minus 6. The width. Okay, number 19 wants you to find the solution. So here's the thing. You could plug in every single one to see if it worked. I'm going to try it this way, though. Do I have three terms with a plus in the back? Yes. So this sign will appear twice. It'll be 1 and 1. So my solution is negative 1. Let's try it. So does negative 1 squared plus 2 times negative 1 plus 1 give me 0? Negative 1 squared is 1. 2 times negative 1 is negative 2, plus 1 is 0. 1 minus 2 is negative 1. Negative 1 plus 1 is 0. It worked, so it is negative 1. But this one here says negative 1 and 1. All right, let's plug in negative 1 and see if that works. So let's plug in the positive 1 and see if that gives us 0. 1 plus 2 plus 1. I can tell right away that's not going to, so it isn't that one. So these ones don't work. It says number 19 again, just because the formatting was off. But it says factor and then solve. This is already factored, so we just have to set each factor equal to 0 to solve. The zero product property allows us to do that. So x is negative 4 and x is 3. Like I said, the beauty of math is you can check your work. If you plug 3 back in, it will work. Same with negative 4. Here, I have to factor before I can solve. Do you have three terms with a plus in the back? You do not. So one's going to be positive, one's going to be negative. What are factors of negative 8 that give us negative 2, negative 4, and positive 2? Now I have to set each piece equal to 0 to solve. If I add 4 to both sides, m equals 4, m equals negative 2. Okay. Here, I have to get everything to one side, so I'm going to bring that 13 over to the positive x squared. I see that they share a GCF. I'm going to set each piece equal to 0 to solve. Here, I'm going to factor the difference of two perfect squares. And now the zero product property lets me set each piece, each factor, equal to 0. And when I do, okay, you can match these by foiling. It says match the trinomial with its factored version, or you can just actually factor and match. So 2 times 7 is 14. What are factors of 14 that give us negative 15? Well, a negative 1 times a negative 14 gives us a negative 15. So I'm going to rewrite this as 2g squared minus 1x, or 1g, minus 14g plus 7. Factoring these two, they share a g. These two share a 7, but I want to be a negative 7, so that I'm left with a 2g minus 1. So g minus 7, 2g minus 1. Let's find a g minus 7, 2g minus 1. Yep. All right, here, 2 times 3 is 6. What are factors of 6 that give you negative 5? It'd be a negative 2 times a negative 3. So we're going to rewrite this as 2x squared minus 2x minus 3x plus 3. There's a GCF of 2x here, so you're left with x minus 1. And there's a GCF here of negative 3. If you don't get the same thing twice, you have to pull out the opposite. So if the negative 3 didn't work, you take out a positive 3. So now I have an x minus 1 and a 2x minus 3. Here, 2 times negative 4 is going to be negative 8. You're going to get a negative 8 times a positive 1 to get that negative 7. So we're going to rewrite it as negative or positive 2a squared minus 8a minus 1a, or it's positive 1a, I'm sorry, minus 4. They have a 2a in common. They have an a minus 4 in common, so technically there's a 1 here. So it's going to be 2a plus 1 times a minus 4. Okay, we're going to try this again. So why I have it all as matching is, what if you're on the test and you kind of blank? You can FOIL to check your work. So let's try it this way. 2 times 2 is 4. One moment. Excuse me. 4. 2 times 2 is 4. 10. A 4. No, it's not going to be that. 2 squared. Yes. 4x. Yes. 5x. Yes. 10. When I combine like terms, does it give me my original? It does. So that's what you could do if you weren't sure how to do these on your test. On the back, okay, we have at the 4th of July celebration, a rocket is launched into the air with initial velocity. Okay, so here's a rocket. It's going woo, and it comes back down. That's an upside down quadratic. Okay, which, yeah, it's negative. With an initial velocity of 125 feet per second, the height of the rocket in feet above sea level is modeled by this equation, where t is the time in seconds after the rocket is launched. What is the height of the rocket when it returns to the ground? If it goes to the ground, the height is 0. After how many seconds will the rocket touch the ground? So if the height is 0, 125t, we need to find the time because it said how many seconds. You can take out, they both share a t. So take out a t and set each piece equal to 0. So the time would be 0, or the time would be, 125 minus 16t equals 0. Well, yeah, the time would be 0 when it starts, and then how many seconds after when it ends. So I subtract 125, and then t equals 125 divided by 16, which is